everyone, I am Saloni Jaiswal. I am from International Institute of Professional Studies DAVV. My subject is Information Security and this is a test 1 assignment video under the guidance of Dr. Shaligram Pachapas sir. So the question is, there are three basic approaches to authentication of a user. So one is a unique characteristics of the person such as a voice or fingerprint, second one an item that the person has such as a machine readable badges and keys, and the third is a procedure that the person knows such as a password. So if the password is increased in a length, it is a more secure against the threat of an interloper attempting to discover it by brute force attacks. How much time will it take to break a password in this way? So the answer is half of multiply number of possible password into times to enter one password. And the second is, if the data entry and transmission rate is t character per minute, the number of characters involved for entry and replying in a login attempt is L characters, the length of the password is X character, and the number of letters and numerics from which the password is selected is N characters, then the time to break the password will be. So the answer is half of into n to the power x into L upon t. Third is, calculate the expected save time if brute force attacks is carried out by truly working at a keyboard with a data entry rate t equals to 120 characters per minute. The character set size n equals to 20 characters. The password length is 6 character and the number of character L is the login is 15 character. So the answer is half into 206 into 15 upon 120 minutes. So the answer is 7.6 here. Then calculate the expected save time if the exhaustive searches arrive by two machines in a parallel for the above data in point C. So the answer is, if two machines are working in a parallel, then twice as many passwords can be cracked in the same amount of time. Therefore, the expected time to crack the password using two machines in a parallel would be half the time it would take with only one machine. Expected time with the two machines 7.6 years upon 2 equals to 3.8 years. And the last is, calculate the length of a password. If 26 characters are used to create a password, then it will have the probability of not greater than 0.001 of being discovered after systematic attack of 1 month. The data entry rate is 300 characters per minute and the login entry requires character. So answer is by using Anderson solution, and this is the answer. Second question, illustrate the public key implementation of Ravesh, Shamir and Edelman with p equals to 7 and q equals to 11. So step 1 is the two prime numbers p and q are selected. It's p equals to 7 and q equals to 11. Second step, then the two numbers n and r are calculated as n equals to p, q equals to 7 into 11. Then solve 60. Then step third is select an integer e where e is less than r and e has no common factor with r. Take 3 equals to 37. Step 4 is calculate the integer d where e d equals to 1 mod r1. Then the answer is 13. D value is 13. And the last step, the decryption key, the secret key is 13,77 and the decryption key, the public key is 37,77. Thank you.